In this video, what we're going to do is solve some probability problems that will involve using combinations. So we'll start by reading the problem. A company manufactures 4 styles of kayaks: a solo sit-in kayak, a solo sit-on kayak, a tandem sit-in kayak, and a tandem sit-on kayak. Quality control will randomly select 5 kayaks from a manufacturing run in order to test the reliability of the kayaks. If in a given day the company manufactures 12 solo sit-in kayaks, 10 solo sit-on kayaks, 8 tandem sit-in kayaks, and 7 tandem sit-on kayaks, answer the following questions concerning the choosing of the kayaks. A. Find the probability of randomly choosing 5 solo sit-in kayaks from the total manufacturing run. B. Find the probability of randomly choosing 5 tandem sit-in kayaks. C. Find the probability of randomly choosing 3 solo sit-in kayaks and 2 tandem sit-on kayaks. D. Find the probability of randomly choosing 2 solo sit-on kayaks, 2 tandem sit-in kayaks, and 1 tandem sit-on kayak. So the first thing that we want to talk about is the fact that this is going to be a comparison of combinations. We're going to compare to the total amount of kayaks in the manufacturing run, and what we're going to compare to that is going to be the randomly choosing of the different scenarios in the 4 parts of the problem. So we'll start off with first finding or establishing the denominator, because what we'll be looking at whenever we try to calculate these things is going to be something that looks like this. The probability of X, whatever that might be, is going to be equal to some combination in the numerator over a combination in the denominator, and I'm going to just use different letters to establish that they will be different. It's going to be based on the number of items that we'll be talking about. So let's remember that we have a total of 12 solo sit-in kayaks, 10 solo sit-on kayaks, 8 tandem sit-in kayaks, and 7 tandem sit-on kayaks. So what we want to do is go ahead and add that up, and that means that we have a total of 37 kayaks. And this is going to allow us to determine our denominator. So n is equal to 37, and that's going to go into our denominator because that's the total number of kayaks that we're looking at. Also, if we look very carefully at the problems, we see that in part A, we are going to choose 5 solo sit-in kayaks. And that should be referenced back up here where we say that quality control will randomly select 5 kayaks from a manufacturing run in order to test the reliability of the kayaks. So that means that for this particular denominator, R is going to be equal to 5. So that means that we will have 37 C 5. That is going to be the denominator for all of our problems because we have a total of 37 kayaks and we are going to choose 5 of them to test. However, keep in mind that we have 4 types of kayaks and we have different numbers of those 4 types of kayaks. So let's talk about part A. So part A says find the probability of randomly choosing 5 solo sit-in kayaks. Solo sit-in kayaks. And that's going to be important because we need to know how many solo sit-in kayaks were manufactured. We realize that that's going to be 12 right here. So now what we want to do is consider the ratio of choosing 5 solo sit-in kayaks out of the group to our total run. So for part A, it's the probability that we are going to choose 5 solo sit-in kayaks. Which means that for the 5 sit-in solo kayaks, we know that N is equal to 12. That's going to be the solo sit-in kayaks. And we are going to choose 5 of those solo sit-in kayaks. So the probability of choosing the 5, and we're going to call it SSI kayaks, so I don't have to keep writing this all out, is going to be the fact that we have 12 solo sit-in kayaks, and we're going to choose 5 of them. And we're going to compare that to the fact that we have 37 kayaks total, and we're choosing 5 of them. And we will then type that into our calculator to get an answer. And we're going to use web 2.0 calc.com as our online calculator. And you'll notice right here in the lower left-hand corner, it says combinations. And we're going to left click that, and that will put the NCR up in our window. And so what we need to do is type in N, comma, and then R. So our N in this case is 12. And then we'll type in the comma, and that will give us 5. And that's our combination, and you'll notice that it puts the entire formula together for us. But we are going to go ahead and close the parentheses, and we're going to divide by this bottom in the denominator. And we'll left click the NCR again. We'll type in 37, comma, then we'll type in 5, and we'll close the parentheses. And you'll notice that we are going to be doing the 12C5 divided by the 37C5. We go ahead and hit enter, and that gives us our probability. And you'll notice that it's a very small probability. Okay. The reason being is because we have 37 kayaks. We're only choosing 5, and there are 12 of the sit-in solo kayaks that we're concerned with. So let's round this to 4 decimal places, 0.0018, and that would be an approximate. So I could go ahead and just write this as an approximate symbol, and it's 0.0018. Now, one of the things that I want to point out here is since there are 4 styles of kayaks, if I'm going to be testing more than one style of kayak in the numerator, we'll be using the multiplication principle. And one of the things that I want to show you right here is the fact that we could go ahead and establish a pattern right now based upon this. Remember, there are 4 styles of kayaks. And we need the numbers of the kayaks. And I've gone ahead and rewritten the numbers for each one of the styles. We have 12 solo sit-ins, 10 solo sit-ons, 8 tandem sit-ins, and 7 tandem sit-ons. Keep in mind that if I'm going to do combinations for this, for the solo sit-ins, I would write this as 12C, and then I'm going to have my R, depending on how many I'm going to choose. And like I said, that's for the solo sit-ins. I could also write for the solo sit-ons 10C, and that would be an R, whatever that would be the, or I should say that would be the amount that I'm going to choose, and that would be your solo sit-ons. Then for the other 2, I would write these templates basically, and this is going to be for my tandem sit-ins and my tandem sit-ons. Now, in the problem that we just did, we wanted to find the probability that we will choose 5 solo sit-in kayaks, which means that we are, if we choose 5 solo sit-in kayaks, then we will choose 0 solo sit-on kayaks, 0 tandem sit-in kayaks, and 0 tandem sit-on kayaks. Which means that for all 3 of these that I've just put dots next to, that means that R is going to be equal to 0. And there's a reason that I'm doing this, and let me show you. Because if I go ahead and write this probability out of the 5 solo sit-in kayaks, that's going to be equal to the fact that I have 12 solo sit-in kayaks, and I'm going to choose 5 of them. I'm also going to multiply that by the fact that I have 10 solo sit-on kayaks, but I'm not choosing any of them. I'm going to multiply that by the fact that I have 8 tandem sit-in kayaks, but I'm not choosing any of them. And I will multiply that by the fact that I have 7 tandem sit-on kayaks, but I'm not choosing any of them. And then I will divide that by the total, which is the fact that I have 37 kayaks and I'm choosing 5 of them. If I go ahead and punch all this into the calculator, I'll still end up with the same answer of 0.0018. The reason that I show this to you is because if you notice that the numbers on the left of the C's, this would be your N's in the numerator, if we add those together, that will be equal to the number, the N, to the left of the C in the denominator. And then likewise, if we look at the numbers to the right of the C's, i.e. the R's, and we add those together, we end up with the R in the denominator. The reason I show you this is because this gives us a template for when we are choosing multiple types of kayaks at random. So let's go ahead and do part B. Part B says find the probability of randomly choosing 5 tandem sit-in kayaks. Well, that means that I'm going to choose 5 of the tandem sit-in kayaks. I will choose 0 solo sit-in kayaks. I will choose 0 tandem sit-on kayaks and 0 solo sit-in kayaks. Or I'm sorry, 0 solo sit-on kayaks. Once again, the probability is going to be 5 tandem sit-in kayaks, which means if I use the same premise or the same style that I used previously, I can go ahead and combine all this. So 5 tandem sit-in kayaks. We have 8 tandem sit-in kayaks. So we're going to take 8 kayaks and choose 5 of them. Likewise, we're going to multiply that by the fact that I have 12 solo sit-in kayaks, but I'm not going to choose any of those, times the fact that I have 10 solo sit-on kayaks, but I'm not choosing any of those, times the fact that I have 7 tandem sit-on kayaks, but I'm not choosing any of those. And that's all going to be divided by the fact that there are 37 kayaks and I am choosing 5 of them. Now this numerator tells me what styles I'm choosing. The denominator just tells me that I'm choosing kayaks. So once again, I will plug this into my calculator and I'll use Web 2.0 Calc again. All right, so we'll do the choosing, and we'll do 8 choose 5. And now for the 12 choose 0, 10 choose 0, and 7 choose 0, I really don't have to put those in there because those are each going to be equal to 1. And like I said, the only reason that I'm doing this is because when we start to use multiple different numbers from each of the groups, we need to have more than just one combination. So I can go ahead and I can divide this by the 37, choose 5. And I'll go ahead and hit enter. And notice that we get an even smaller probability than we did before, but that should make sense because we have fewer tandem sit-in kayaks than we did from the others. So that's going to be 0.0001, and we'll round it to 1.3. Okay, part C says find the probability of randomly choosing 3 solo sit-in kayaks and 2 tandem sit-on kayaks. And this is where the reason that I divided it up the way I did is really going to become important. So this is the probability of choosing 3 solo sit-in kayaks and 2 tandem sit-on kayaks, which means that once again, this will all be over 37 C5 because I have a total of 37 kayaks and I'm going to choose 5 of them. However, now I'm going to be choosing from 2 different styles of kayaks. And so for the sit-on or the solo sit-in, remember I have 12 of those, but I'm only going to choose 3 of them. And for the tandem sit-ons, I only have 7 of them, but I'm going to choose 2 of them. Now this is where you're going to pay attention to the N's and the R's. Notice that this number plus this number, 12 plus 7, is only going to be equal to 19. But if we look at this very carefully, we know that we have 2 other styles of kayaks. We have the 10 solo sit-ons, but we don't choose any of those. And we have 8 of the tandem sit-ins, but we're not choosing any of those. Now, if you add these numbers together that are enclosed in the blue box, if I add 12 plus 7 plus 10 plus 8, I end up with 37. And then, if I look at what's in the dark blue circles on the right-hand side, which is going to be our R's, 3 plus 2 plus 0 plus 0 is in fact 5. And now I can plug this into my calculator and I will come up with the correct probabilities. So we'll start with the numerator. And as I said, this value right here, this first one, will actually be equal to 1. And this one will be equal to 1. So I really don't have to put those into the calculator. But let's go ahead and do. And so we'll start with the first term, which is going to be 12 comma 3 here. We're going to multiply that by and that'll be, the next one will be 7 comma 2. Now obviously it's going to depend upon what kind of calculator you're using and how you enter this. I will go ahead and close the parentheses. And just to show you how this is all going to work out, I'm going to go ahead and put in both of these terms or factors so that we can show how it actually works. So then we're going to multiply, and we're going to have 10 comma, 0. And we're going to do that again, except this time it'll be 8, comma, 0. And now I'm simply going to divide. But notice that there's a problem with my calculator here. I didn't do all the types of notations that I needed. So let me back up and let me put parentheses around the outside of everything. That way I have my numerator, and then I'm going to divide by my denominator, and that's going to be 37. Oops. Sorry, we got to choose the NCR first. 37, comma, 5. Close the parentheses and hit equals. And I end up with 0.01059, which we were around to 0.0106. And you'll notice that this probability is much larger than what we had previously. Okay, so let's go ahead and crank out this probability, which is going to be 2 solo sit-ons, 2 tandem sit-ins, and then 1 tandem sit-on, which means that I will actually have no solo sit-in kayaks. So we'll write out our combinations. Okay, so we have 10 solo sit-on kayaks that we are going to choose 2 of. We have 8 tandem sit-in kayaks that we're going to choose 2 of. We have 7 tandem sit-on kayaks that we will choose 1 of. And then finally, we have a total of 12 solo sit-in kayaks, but we're only going to choose 0 of them or none of them. And that's all going to be over the fact that we have a total of 37 kayaks and we're going to choose 5 of them. Once again, you want to go ahead and key this into your calculator, and you will end up with the following. So I've gone ahead and entered this entire expression into the calculator, and we'll go ahead and left click equals, and we end up with 0.0202. And that's the probability for choosing 2 solo sit-on kayaks, 2 tandem sit-in kayaks, and 1 tandem sit-on kayak.